Alright everyone, welcome to video 2 of the AAQ of Unit 2 Chemistry, and in this video we're going to cover quite a bit more. We're going to cover energy levels, which is our shells, subshells, electronic orbitals. We're going to show the rules for the electronic structure of the atoms and how to draw electron configuration from atoms 1 to 36. Let's start off by breaking down electronic structure first of all. Everything you can see here is going to be definitions. I don't know, just read them out to you, but I will. Electrons move around the shell in energy levels. So you can see this is previously what we identified as the shells that the electrons were in. Now there's a little bit more nuance to that. A further shell is from nucleus, the higher it goes up in energy. So this one has a lower energy than this one. And each shell is given a number or a principal quantum number n. Now you don't need to be aware of the principal quantum number n, but you do need to know that this one is 1, this one is 2, this one is 3, this one is 4. That's it. The shell number corresponds to how many electrons they have. So in number 1, we have 2 electrons. In number 2, we have 8. 3, we have 18. And 4, we have 32. I think there are easier ways of working this out, but you can just remember this if you need it. I would prefer if you worked it out. Now let's look at subshells. The shells themselves are made up of different subshells which have different energies, and each of those subshells have different orbitals. And in those orbitals, we can have 2 electrons. Now, this just sounds like an awful lot of words, but I'll show you visually what this means in a minute. And an orbital is a region of space which can hold up to 2 electrons with opposite spins. Again, loads of new information that you're not aware of, but I've color-coded it, and this is going to make a bit more sense in the next bit. You might have to rewatch this. So there are 3 subshells that we're going to look at. We're going to look at S, we're going to look at P, and we're looking at D. And we're going to represent them in these boxes. So you might have seen something that looks like this before. It looks kind of scary, but it is quite simple. You've got a 1s, a 2s, a 2p, a 3s, a 3p, a 4s, which is a bit of an odd one out, and then a 3d. And now we just need to learn this pattern. By the end of this video and the end of your practice and then the end of the week of lessons and questions, you should know this off by heart. So for now, we just accept this is the way, and I'll break it down as we go along. Each of these shells is represented by a number. So you can see here, this is 1, this is 2, well, these are 2, these are 3, and this is 4. So it goes up by that. And then each of those has subshells, which is going to be the S, the P's, and the D's. And then each of those has orbitals. So every box here is an orbital. And that's how we're going to break that down. So there's some of the key terms and what they actually look like. Now, 2 of the things that you will need to be aware of is orbital shapes. So around that atom, we have electrons spinning around, and they're going to be spinning around in their respective orbitals. And if it's in an S orbital, it's a sphere, so it looks like a sphere with 2 electrons whizzing around inside of it. And all S's look like this. They just get bigger. So this would be like a 1s, this would be a 2s, this would be a 3s, this would be 4, that would be 5, that would be 6, 7, you get the idea. Now, with p orbitals, we call these dumbbells. There's only 2 shapes that you need to know. S is spherical or sphere, and P is a dumbbell, which is this guy right here. So our p orbitals look like this. So this box would look like this one. This box would look like this one at this angle, and this box would look at this one at this angle. So they're all dumbbell shaped, and the electrons in these whiz around in these areas like that. But you just need to know S is sphere, P is dumbbell. And it looks like these. Now, you do need to be able to draw them, but if you draw them just like this, so sphere and a weird looking number 8, which is a dumbbell, that gives you the mark. And that's essentially what you need to know from this section. Now, let's go back to this here, because I would like you guys to complete this, and it will take you a little bit of going back and forth. You're not just going to be able to spit them out, but have a good look at read these questions, pause the video, use the information here in the table to help you answer these questions, and it should give you a better understanding by the end of it. I have listed them down here for you as the correct order, and I would just like you to learn the correct order. I don't want you to get this bit wrong, so I have given you the answer, and I would like you to copy this one out. Note here that the 4S comes before 3D. That's going to be really, really important every time we do this. Pause the video, have a go at this task, and then I'm going to move on to the next section. Right. So electron configuration. There's quite a few rules for this, and what I'd like to do is I want to show you how to do this step by step. So let's get rid of this. I'm going to give you the answer anyway, but I want to take you through it step by step. So electrons are filled up from the lowest subshells first. So we start at the bottom and we work our way up. So that's what that means. Start at the bottom, work your way up. orbitals are filled singly first before they start pairing. So what this means is when we get to P, and don't worry, I'll show you this in practice, we do one electron here, one here, and then one here. A bit like people on a bus when they get onto one seat, and the person gets on another seat, and eventually when all the seats are taken, we start pairing them up. He sits there, she goes there, and they go here. So that's essentially how they're going to be paired up, just like that. The next rule that we need to know is that the two electrons sharing opposite must have opposite spins. So just how you saw me draw them, one arrow, half arrow going up, one half arrow going down. It doesn't matter which way around, but you just need to make sure it's half and half. There are some more nuanced rules here, but I'll go through those as I take you through this one. So the example I've got is complete an electron inbox diagram for calcium. Calcium on the periodic table, little number, you can see right there, this time it's on the bottom, is 20. It means it has a proton number of 20. If it's got 20 protons, it must therefore have 20 electrons because it's neutral. So therefore we've got 20 electrons to play with. Let's fill these out the way that I would do this. So you can do this with me, but for now, just watch how I do it. I've got 20 electrons. I'm going to go 1, then 2, 3, 4, 5, 6, 7. Now we pair them up. 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then we've got 2 more, 19 and 20 goes into the 4s. Now the electron configuration, this is the way that we write it. So you're going to get really used to hearing this. It goes 1s2, 2s2, 2p6, 3s2, 3p6, because I've got 6 there. And the one that you guys are missing is 4s2. So 4s, and then we do to the power of 2. So it's like a little 2 at the top. And that's how we do electron configurations. And I've left the periodic table there for you, so you might have to flip your periodic table to find these out. I will go through the first one with you, just to give you a little bit of confidence. So, task to complete the following. I would like you to complete these. So I'm going to highlight this for you. And we're going to look at N. N is nitrogen. This is in group 5. This is over here. Little number says 7. Easy way to do this is I would write the number of electrons that you've got to play with there. 7 electrons. Now, just like before, we're going to start from the bottom. We're going to work our way up. And we're not allowed to fill them doubly until we fill them singly. So we've got 7 electrons. Let's have a go at this. So we've got 1s, 1, 2, 3, 4, 5, 6, 7, and then we stop. Got 7 electrons there. Now the electron configuration for this, you've got 1s2, 2s2, and then here we have 2p3. And you can see in the 2 subshell, we have 5 electrons, but we got 2 NS and then 3 and 2p. I would like you to do the same for magnesium. So if you zoom out, you can see magnesium has 12 electrons. And I want you to do the same process, but I want you to complete it for magnesium, for sulfur, and then for scandium. Scandium might be a little bit tougher because we got 21, but I would just follow the outline that we got right here. All right, good job, guys.